Hey everyone, this is You'll Be Blessed Education here, making it clear and making it plain in the concept of understanding periodic trends, specifically the atomic radius. So today you will be able to describe the trends in atomic radius in order to discuss the effects of subatomic particles on the chemical properties of atoms. All right. And so the basic concept behind all of this is that interactions between particles exhibit patterns. Today's pattern is the atomic radius. So let's begin. When we want to measure the atomic radius, it's actually difficult to do that for an individual atom. So therefore, we have to measure half the distance between two combined nuclei, and that is usually measured in picometers or angstroms, okay? And if you look to your right, we have atom A and atom B, and they're meant to actually be identical despite them having two different letters. But if you look at the center of atom A, there is a line with a dot on one end that extends to the overlapping section between atom A and B. And where that dot ends, that is actually the distance, but half the distance between the two nuclei or the centers of those two atoms. And that's how we measure the atomic radius. All right. So let's dive into the actual trend. The first trend I'm going to give you is a little bit easier, and it is as the atomic radius goes down the group. Okay. And basically, the atomic radius increases as you move down the group, simply because as you add energy levels, the atom gets larger. So any atom that has two energy levels is automatically larger than an atom that has one energy level. All right. And then it's safe to assume that any atom that has seven energy levels is larger than an atom that has six energy levels. That is the basic pattern. Now, is this true for every single atom on the periodic table? No, but the thing is, this is really to help you predict patterns, not necessarily know all the exact numbers off the top of your head. All right. And so let's go ahead and dive into some examples. Which of these two atoms are larger or has a larger atomic radius? We got magnesium with an atomic number of 12 and strontium with an atomic number of 38. Okay, so choose an answer. And I'm going to choose strontium 38. So why is strontium a larger atom than magnesium? Well, they're both in the same group on the periodic table, which is group 2. And since we're talking about how we're comparing elements as we go down the group on the periodic table, all right, the explanation has to be because of the energy levels. And so because strontium has more energy levels, it is larger than magnesium. Let's dive into another example. Which of these two atoms has a smaller atomic radius? This time we're looking at oxygen with an atomic number of 8 and selenium with an atomic number of 34. So you choose. Which one, oxygen or selenium? Which one is smaller? And the answer is oxygen. So why is it that oxygen is smaller than selenium? Again, we're talking about going down the groups in the periodic table. So we're still talking about energy levels. Therefore, the answer is B. It has fewer energy levels than selenium, and therefore, oxygen is smaller than selenium. So now that we've looked at what happens to the atomic radius as you go down a group, let's look at how it goes across the periodic table. Okay, so the atomic radius decreases as you move across each period. And why does this happen? Basically, the atomic number or the amount of protons is actually increasing as you go across the periodic table. Let me make sure I'm getting my hand motion right because I have no idea how this is going to look on camera. But basically, as you go from left to right, okay, you're going to add protons, which adds nuclear charge. There's more positive charge. And the more positive charge you have, the tighter the hold is on the electrons. And this primarily works when you're traveling in the same period, okay? The same period. This rule can get fuzzy if you're trying to compare elements that are in different periods, okay? So that's why I introduced the previous trend first, because that's easier, and I believe it trumps this one first. Okay, and so let's dive into an example. So which of these two atoms has a larger atomic radius, calcium or bromine? You decide. I would choose calcium, and because we're looking at calcium and bromine, we have to first recognize that they're in the same row on a periodic table or the same period, which is period 4. So then why is calcium smaller? I'm sorry, why is calcium larger in atomic radius than bromine? And the answer is because it has fewer protons. Remember, if you don't have as many protons and you're in the same period, then you have a weaker attraction for the electrons and you don't hold on to them as tightly. Okay, let's try another one. So, which of these two atoms has a smaller atomic radius? Is it carbon or is it neon? You decide. Now, if it were me, I would pick neon. All right. Carbon and neon are on the same row or same period on the periodic table again. And so, why would neon actually be smaller than carbon? So, in order for neon to be smaller than carbon, it needs to have more protons or have a higher nuclear charge. So, because there's a higher nuclear charge, it is pulling on those electrons a lot more tightly than carbon, and that qualifies it to be smaller in size than carbon. All right. So, this is a basic recap of the lesson for today. This is a map of the atomic radius across the entire periodic table. The dark regions represent areas of atoms of high atomic radius, while the light regions represent atoms of low or small atomic radius. And the white regions are the ones or atoms that actually have immeasurable sizes simply because, they're radioactive. We don't really try to combine them with anything, so we can't measure their atomic radius. All right. So I hope you were blessed by today's lesson. And if you need to look at any of my other videos on the periodic trends, make sure understanding periodic trends, make sure you check it out. Have a blessed day. This is You'll Be Blessed, and I'm out.